Hi guys, in this video I'm going to walk through this eco number 42, trapping rainwater. So let's look at the graph in here. We want to calculate how much rain water can be trapped in this graphic. So for example, the height for the first bar is 0, so there's no height. The height for the second bar is 1. And the height for the third bar is 0. So some water when it rains from the sky, and then it traps 1 unit of water in here. And similarly, for this one, it traps 2 units of water. As you can see, and how much water is get trapped, it depends on the maximum height on the left hand side and the maximum height on the right hand side. So for this particular case, the maximum height of on the left hand side, when we look back to the left, is 2 2 unit of height, and when we look to the right, the maximum height is 3, and then we take the minimum. We take the minimum of the 2, because when we go the minimum is the highest we can reach. That's why we need the minimum of the highest between the two area, between the two directions, and then we take that to the difference to the height itself. In this case, this distance is 0. So it's a minimum of 2 and 3, and that equals to 2 minus 2 minus 0 is equal to 2. And I have these 2 YouTube videos to walk through the idea and also the algorithm. And in this video, I'm going to implement in Python code. So first one, we have the left max. We initialize as array, and we can do that by this length f max, and we need it as a list. This is how we can do it. Do the same thing to the right. So the left max is the right max, is the cumulative height at that point. For example, the left max for the first unit is 0, second unit is 1, the third unit is 1, fourth at the first unit is 4, is 2. That's why it's just look at that point and then look back to the left and look back to the right. So after we have that, what we need to do is have a for loop to implement that formula. So we have the formula. Formula is the minimum of the left max and the right max minus the height itself, and that need to be greater than or equal to 0. So that's our formula. Let's go implement it. And I will write a function at the end to fill out these two lists. But just now, it's to pretend that we have this two lists already. So for So is equal to, so we collecting all the height, all the collecting all the water, plus basically we can just use this formula, and yeah, we can do that. You know what? Just make it easier like this. And we need to return the result. Okay, the next step is to fill out these two lists. So notice that when we look back to the left, it's not including the cell. So for example, at this spot, when we look to the left, the maximum height is 2, which is this bar. And when we are at this spot, when we look to the right, the highest is 3. So when we look back, it's not including the cell. I think the default case is better to be 0, because that's the edge. So let's figure it out. For we do the same. Then we can have a running max to save some runtime. We can start it from the first guy. First, start from the second guy, because the first guy is automatically 0. Because when you look at here, the left max is already 0. It must be 0. So we can start from the second guy, and we have the running left max, and that's from 0. Let's change it to index. So that's the index, and that is equal to the maximum of a running max and the current number. Right. One. Yeah, I think it's easier to just do a eating word. So we can get the element as well. And yeah, so this is Yeah, we can do that. Plus 1. Maximum of E. Yeah, the reason why we plus 1 is because we already have the first element is 0 already. So it's the maximum of the running max. And the element. I think what we can do is running max is equal to max, the running max, and do this. Yeah, this is going to be a big O of n because we just looping through the element instead of looking back all the way. We will only compare one at a time, which will have the running max. Sorry, so this one should be the other way around, including the first one, but not including the last one. And we can do the same thing for the right max. So slight modification is to have this one is gonna reverse the list first, but the rest is the same. Yeah, this is must still the running max. Here, gonna be this guy over here, like this. Let's see. I'm gonna pause the video and see which one. Oh, I think the fix was here. So it should be the index and the height and the rate and yeah. So it's making 11. Sorry, I fixed an formula here, so should be looking at n minus 1 minus n because this right max, that matrix is not that list is the index is strange, so we need to do the inversion, and that works out, and this is the solution. And yeah, it looks pretty efficient. And yeah, this is my video. I hope you like it, and see you next time, hopefully. See you.